So I want us to be able to treat as many questions as possible from what we are going to do now. I have this question here. Let's start with that and see what you have to say. The question says, listen, don't write any, just listen. Is a part of questions we'll be expecting. Comes 2024 UTME. The question says, which of the following metallic hydrides exists as an inorganic polymer? Which of the following metallic hydrides exists as an inorganic what? Polymer? A, calcium hydride. B, magnesium hydride. C, sodium hydride. D, potassium hydride. Who has any idea? The question is, which of the following metallic hydrides exists as inorganic polymer? A, calcium hydride. B, magnesium hydride. C, sodium hydride. D, potassium hydride. No idea. Even if I repeat the question 100 times, that you don't know it, you don't know it. If it's a question, if it's something you know, the moment I mention that, you are supposed to know the answer immediately. So you don't know it, that's what it means. Any question you read twice and you don't know the answer, that means you don't know, you forget about it. So we move now. I want us to treat at least 50 questions before the end of this class. So let's move. The first thing I want us to treat is hydrides. Hydrides. Who can tell me what a hydride is? I would like to go with my this, because if I drop it now, I will not be able to complete my task. I need to control myself. Hydrides. Who has idea of what hydride is all about? Anybody? Okay, note down. A hydride is a chemical compound. A hydride is a chemical compound. A hydride is a chemical compound composed of hydrogen. A hydride is a chemical compound composed of hydrogen and a metal or a non-metal. A hydride is a chemical compound composed of hydrogen and a metal or what? A non-metal. So, first up, from this note now, who can tell me how many elements make up a hydride? Is it 2 elements? In chemistry, we have what we call binary compounds. The word bi has to do with what? So we have binary compounds. That's compound that consists of only what? 2 elements. In a compound must have 2 or more elements, isn't it? Yes. So when a compound has just 2 elements, then it is known as what? Binary compound. Don't write anything. I don't want anybody to write when I have not asked you to write. When I'm not asking you to write. Now, what of this? What if a compound, like something like this now, is it a binary compound? Watch this. No. Is it binary? No. Why do you say so? Is it 3 elements? Yes. 3 elements, not 2. But what about this one? Is it binary? Yes. What about this one? Is it binary? Yes. Okay. What about this one? Is it binary? So what about this one? Is it binary? Yes. This big thing is binary. Yes. Are you sure? Yes. Why do you say it's binary? Only 2 elements. What are the elements? Can you identify them? That's all. Carbon and hydrogen. So you can now see that all the compounds you call hydrocarbons are what? Hydrides. They're all binary compounds. Are you there? But look at this one now. At now, remember I said, do not, if I catch you writing, you're in trouble. What about this one? Something like this. Something like this. Is it a binary compound? Okay, so when a compound has 3 elements, what do you call it? Trinary. Not trinary. We don't use tri there. I'm not EU, okay? Sorry. EU ternary. Ternary compound. About trinary. I might use try about. Even a Latin, even a naming system. And when one use die, when one use buy. And an if neku. Hey. And we buy die. Okay, man, you need a miniature too. Okay, ma. Thank you. Ota if you want 3 and we try and we tell. That is TEN. Okay? So it also means 3. When it comes to 4, don't write anything. When it comes to 4, you also have quadri, right? Quadri, tetra. All these things are words that the prefixes you can use to represent what? 3, right? Okay, 4, thank you. So that is it. No problem. So that is just the idea I want you to have. So you should be able to know when a compound is binary. Now, let me also help you with this. We have what we call oxide too. So from what we just did now, can you tell me what an oxide is? An oxide is what? Yes, an oxide is a chemical compound composed of what? Oxygen and what? A metal or non-metal. So that is science. You need to understand concept and then you expand that concept. So the same way you have a hydride, that's the same way we have what? An oxide. Okay? We still come to oxide so that we'll learn the classification, methods of classifying oxide. Can you tell me any oxide you know? Like by class? So is this an oxide? Is this an oxide? Something like this. Is it an oxide? Is it an oxide? Yes. Are you sure? Yes. Okay, because what you are seeing here is oxygen and what? Thank you. So the same way, so whenever you have hydrogen and just one other element in a compound, then that compound is what? A hydride. So by right, is this a hydride? Is this a hydride? Yes. Are you sure? Yes. Hydride of which element? Hydride of nitrogen. Like this one now is oxide of aluminium. So this is hydride of nitrogen. What about this? Is it a hydride? Yes. Hydride of what? Have you seen this before? Have you seen this before? Okay, I've not seen this one. Okay, it's okay. All these are things you encounter in your jam. We're going to discuss them now, is it right? Then your jam pass questions. So what do you call this one? What's the common name for this one? Do not write. Remember, learn how to do what? Let us learn how to put much thing in our brain than in book, is it right? So what is this? Ammonia. What is this one? Phosphine. Phosphine. Now watch again. Watch this one. Now. Who can try lock here? Jesus. Ataratate. Kenka. Say asin. Edekwana anything. Nweta ki ide ihe. Gemut. Obu na ide kpakpam. Ama m ihe eme gị. Ngwa na-enegodu nke ka onye agwa m afa nka. Ka onye nwee ike isi apart from kakwifu na ndị a na end na in ọkwa na afịa. Inwe ike guess nka ka element symbol ya bụ SB. Ka element symbol ya bụ SB. Ka element symbol ya bụ SB. Anti-money. Say anti-money. Anti-ego. Anti-money. Oh, yeah, SB. Anti-money. So, in wiki guess nka now. Anti-money, okay? Dagi aburota. On a juro where you keep a mail. Say, and we are basar and where be for be a benny. And where be for be here. Baby is in the symbol. And where be for Seba. But S is in the symbol. So it means the symbol is not taken from this name. Because symbols of chemical element are taken either from the current name or from the ancient name. So the ancient name for antimony is stibium. Can you see where the S and B are taken from? So can you guess now what I should call this? Stibine. I hope you know what if you know there. Because you are gets bar now. You gets bar. Mutakuko. Nchoki ide ife mkpolo gigini something to write. Okompolo gi ife there. You gets bar. The kwakam kona biana on the Iye buki buton wena. Don't start no one you. Man, otiga kama could be madi on. Okay, right. All hydrocarbons are hydrides of carbon. All hydrocarbons are hydrides of carbon. All hydrocarbons are hydrides of what? Carbon. Any nebu hydrocarbon, beginning hydride of what? Carbon. Akwenwa alkanes up here. We have alkanes, we have what? Alkenes, we have alkynes, do you remember? We also have arenes, and so on. Emankebarine. Emankebarine. Okay, mararine. Are. Web afia barin zeba. Ngwana eba arin bu abu na compound nwe gini benzene ring we nwekwazie aromatic chain like something of this kind. Something like this now. This man, is it aliphatic or not? This particular thing, is it aliphatic? Yes. From where? Kebes went here from this, right? Yes. From methane. But this one is benzene, true of us. Yes. So this is an arene. It's an arene, it belongs to the arene family. The name is what? Methyl benzene, or also known as what? Toluene. Also known as what? Toluene. That's not what we're discussing. So every by the way, is this, look at this compound here. Do you think, is it a hydride? Yes. Is it a hydride? Yes. If I write the formula now, it is C6H5CH3. The whole of this is what? C6H5. Are you there? So do you think this compound, is it a hydride or not a hydride? It's a hydride. We said all hydrocarbons are what? Are hydrides of what? That's all. So that's by the way. Now, write a small heading. Classes of hydrides. Classes of what? Hydrides. Agwangi maki say dey. The only about a ton and come my dear. Classes of what? Hydrides. So, anyway, ionic hydrides. Yes, right. Ionic hydrides. Anyway, negative of mouth. Anyway, covalent hydrides. Covalent hydrides. Anyway, interstitial hydrides. Hydrides. Then anyway, quasi electron deficient. Electron deficient covalent hydrides, which are polymeric hydrides. So these are 4 classes of hydrides. You will need to listen attentively. Now, listen carefully now so that you will know those that are ionic and those that are what? Covalent. Now, if we go to, for us to understand this better, we need knowledge of periodic table. If you come to group 1, we have group 1 or 1A, IA. 1 as a digit or IA in Roman system. What are the members of this group? Can you tell me the members of this group? What are they? Hydrogen is not a member of group 1. Hydrogen is not what? A member of group 1. It is not. So be very careful. The first member of group 1 is what? Lithium. The second member is what? Sodium. The third member is potassium. The fourth member is rubidium. The fifth member is cesium. I hope you know the symbol for lithium. Yes. Capital L, small I. What about sodium? Capital N, small a. What about potassium? Capital K. I hope you know how to write capital K. You don't know how to write it. Now, let me teach you. Now, look at this. Look at this now. Look at these two things. Is there any difference between them? No. Is there any difference between them? No. What is the difference? There is difference. In this one, this line is longer than this one, right? Yes. Here are equal in length. But this one is longer than this. This is small letter K. For this one, both here and here are equal in length. This is capital letter what? K. What makes K capital is if here and here are equal in what? Length. That is K. So is this capital K? Yes. This is potassium. But if I write like this, is it potassium? No. Is that potassium? No. Is this symbol potassium class? No. Why? It's small k. So you have to be very careful of what you do. Be very, very careful. Rubidium, what is the symbol? RB. Cesium. CS. Am I going to write S? Look up. Is this correct? If I write this, is this cesium? No. No is the answer. Why? This S is a subscript. What makes the S subscript? You know, look at this. This is a line. If I have an alphabet like this here, any other one that goes below this is a subscript. But if it's like this, if anything else in the same line with this, then this one is a small letter. So is this a subscript? Yes. But if I write it like this, is it a subscript? So this is cesium. Capital C, small letter S. So that is the writing. Now, we also have group 2. Group 2 or IIA. What is the first member? Beryllium. Beryllium. What is the symbol? Be. What is the second member? Magnesium, right? What is his symbol? Capital M, small g. Like this, right? Huh? What about if I write it like this? Is it correct? Is it correct? It's a subscript. Then we have what again? Calcium. What is the symbol for calcium? Is it correct? Yes. The next member is what? Strontium. What is the symbol? SR. Then finally you have what? Barium. Barium. These are normal elements. Other ones are radioactive. Are what? So we do not discuss them when we are discussing others. Are you there? Like there is still another member after cesium, known as what? Francium, right? So we do not talk about it because it is what? Radioactive. Rubidium is not. So barium, what is symbol for barium? Ba. Now, somebody will ask me, why did I list all this symbol? I listed a symbol for you to understand what I'm about to say now. You see, look up. Look at what we call ionic hydrides. The hydrides of these elements. And look up, from here to here are what? Ionic. So, all the alkali metals, the hydrides of all, you know group 1 are called alkali metals, right? This is called the group name. Listen, we have group and group what? Name. The name for this group is what? For all the elements here is what? Alkali metals. They are known as alkali metals. Metals that form alkali. Metals whose compounds are what? Alkali. That is the meaning of alkali metals. Thank you. So, all these members here, all these members, and from what? Calcium, strontium, and what? Barium. They form what? They form what? So if John asks you now, look at this compound. Now, if I write this, look at this. Calcium what? This is calcium hydride. Is it ionic compound or not ionic? It's ionic compound. It's ionic compound. What about this one? Something like this. What is this? Can you name it? Is this sodium hydride? Who can tell me why 2 is here and there is no 2 here? They are group. You know this one is group 2, right? Why this one is what? So 1 is here. Right? So the 2, look at it here. Are you there? Good. So you can now see that the formula for the hydrides of the group 2 is this. This is general formula MH what? 2. But for the group 1, the general formula is what? MH. What does this M mean? metal. Is that right? So if I want to write formula for N of group 1, I will simply represent M with what? Symbol. Now, can you write symbol for rubidium hydride? Is it possible? Yes. Can you do that? Yes. I'll just write what? RBH. That's rubidium. Is it ionic? Yes. Is it ionic? Yes. Thank you so much. So the hydrides of all of this together from here and here are what? Ionic. They are what? Thank you, we're coming. There's another important feature about them. There's a very interesting feature about them. Look at it. Look at it. Like, for instance, look at this. Ionic hydride. What is unique about them? Of all these hydrides of this and this and this, the hydride of lithium does not decompose on heating. Does not decompose on what? But others decompose on what? What do you mean by something decomposing on heating? There are compounds that if you place them on, let's say, boiling tube, put them in boiling tube and subject them to heating, before, normally, if you place something on fire, what should you do? If you place a solid on fire, it's supposed to melt, right? Yes. But there are some compounds that, look at it and see what we call thermal decomposition reaction. There are some compounds that if you put them in, put them on, subject them to heating, if you heat them, instead of them to turn into liquid, before they could turn into liquid, they will not reach their melting point. They will do what? Break up. They will do what? So when a compound breaks up before reaching the melting point, we say that that compound is what? Undergoing what? Thermal decomposition. Thermal. What did I say? If a compound can break up, if a solid compound can break up before reaching the melting point, we say that it is undergoing what? It's undergoing what? That is the meaning of thermal decomposition. So, of all these ones now, the hydrides of this one, this one, this one, this one, and this one, listen, they undergo thermal decomposition. The only one that don't undergo thermal decomposition is what? Lithium hydride. Lithium hydride do not undergo thermal decomposition. What does that tell you? It means that it will not decompose before reaching the what? Melting point. It can only decompose when it has turned into liquid, right? But all these ones, they will not reach their melting point, they will split. Is that right? Now, see another thing here. For these ones, covalent hydrides, which ones are covalent hydrides? Now, let's look at them. Which ones are covalent hydrides? We have group 14 elements, group 14 or IVA. What are the members of group 14? Carbon, silicon, germanium, Why did I stop you from writing? Because if you are writing, there's no way you can be writing and be what? Listening. I want you to understand more. Because let me tell you again, the exam you are preparing for is not an exam you need to write too many things. It is an exam you need to understand many things. Because it's a multiple choice exam. It's what? It's an exam that will give you a question and give you what? Choice to make. The moment, if you understand, the moment you look at the choices available, you will do what? Recall what you have understood before. But if you do not understand now, remember you have how many months left? Just few months left. Few months left. So that's why you have to be very careful. So this is not an exam where we come here and expect too much lengthy notes like they did in your school before? Or do you want me to appoint class prefect and give you a note to copy? I know, because that can never happen. It is not an option at all. Now let's go to group 14. What are members of group 14? Silicon, germanium, tin, and what? Lead. That's group 14. Now we have group 15 too. Group 15 or what? VA, right? What does the VA mean? 5. What are members of group 15? Nitrogen, phosphorus, phosphorus, what again? Arsenic, antimony, bismuth. Now, finally we have this. Okay, we still talk about them. Group. All the group we mentioned are important. Please, you can jot. You can jot this. You can jot now. Because it will help us to summarize everything and then answer a lot of questions. Group 16 or VIA. What are the members? Oxygen, thank you. Sulfur, yes. Tellurium. Is it selenium or tellurium? Huh? No, selenium before tellurium. Selenium. Tellurium before polonium. Tellurium. Then polonium. Polonium is a radioactive element, so we will not put it. Then you have here group 17 or VIIA. Look up. This numbering system are current ones. These ones are what? Old. What are the members of group 17? Fluorine, chlorine, bromine, iodine. We will not put that one. That is group 17 or 7A. Now, see why I listed all these groups on the board. Look up now. Can you look up? You see, this group 14. Group 14 elements, group 15, group 16, and group 17 form covalent hydrides. They form what? They form what? They form what? Now see, now, look up, look up. If I have this, is this covalent or not covalent? Is this covalent? What is this? Hydrogen fluoride, which is a hydride of what? Is it covalent? Look at it again. Stop writing. We say that the hydride of group 14, group 15, group 16, and what? Are what? Covalent. So you don't need examples of covalent hydrides again. I have given them that is in bundle to you. So all this group, all these elements, they form covalent what? Now, if I ask you now, among the ionic hydrides, covalent, and the other ones, which one are more in number? Is it covalent hydrides? Yes. Because this element here form covalent hydrides. Now, let me also let you know this. Look at this. Look at this. Look at this. Look at this. Everybody. What is this? What compound has this formula? Methane, right? Yes. Now, look at this one. Look at this one. Look at this one. What do you call this one? This is carbon. We call it what? This is methane, right? This is what? Say silane. Say silane. Now look at this one. What do you call this one now? Germain. Germain. What do you call this? What do you call this? No, say stannane. Say stannane. Now look at this. What do you call this? Say plumbane. So all of them, all the hydrides of group 14, group 15, group 16, and group what? 17, they are what? They are covalent. That's what I want you to know. You see, if you understand something, it is very, very good and better. Yes? Thank you. They show one special, some characters. Now, look at this one. You see, I've not talked about these two, right? They were not among the words covalent, right? Yes, ionic. They're supposed to be ionic, right? But they are not. And I did not also classify them as what? Covalent. Because they have another unique character. Unique what? Not that they don't have covalent bond, but there's something they do better. So these ones, beryllium and magnesium, they form what? Polymeric hydrides. Beryllium and what? Form what? They form polymeric hydrides. They form polymeric hydrides. Polymeric hydrides. Now, I have a lot of things to talk about before we go into question and answer. Look at this. Let's look at the hydrides of group what? 17. Hydrides of what? What are the hydrides of group 17? Hydrides of group 17. You know group 17 is same as group 7A, right? What are the hydrides? The hydrides include what? Awesome. Can't you just say, can't you just say hydrogen form covalent hydrides with non-metals? Is tin a non-metal? Eh? Is tin a non-metal? Is lead a non-metal? Is bismuth a non-metal? Bismuth is a metal. Now, hydrides of group 17, look at them. We have HF, we have what? HCl, we have what? HBr, and we have what? HI. What compound has this formula? Name it. This one, don't call it acid. Listen, hydrogen fluoride, hydrogen chloride, hydrogen bromide, hydrogen iodide. When do you say acid? When they are in water. Like this one now, if I put it in water now, it's a gas naturally. But if I put it in water, I will not change the name to what? Hydrochloric acid. Because it's now in what? Water. Okay? So now, of all these things, all of them supposed to be gases. All of them supposed to be what? Gases. Only one refused to be a gas. All of them, what did I say? All of them supposed to be what? Gases at room temperature. But only one refused to be a gas. Touch that girl, she's sleeping. Wake her up. Yes? Who can guess the one that is not a gas? Who can guess? Who can make an intelligent guess on the one that is not a gas? Is it this one? Okay, okay, now look at this, look at this. That's why I say understanding is very, very key to passing UTME. We have this, we have this, we have this, we have this. What is this? What is this? What is the color of this? What is the color of this? Pale yellow. Say pale yellow. What is the color of this? You know, all the halogens have color. All the halogens have what? All the halogens are colored. Is it right? This is pale yellow. This is what? Greenish yellow or yellowish green. What is this? What is the color? Red brown. Red what? What about this one? This one is what? Dark, shiny dark. It's dark in color. In solid state, it is dark. But when it evaporates, that's when it sublimes. The vapor is what? Violet or purple. Violet or what? Purple. This one, look up. In vapor state, the color is what? Violet or what? Purple. But in solid state, the color is what? Shiny dark. Shiny dark. Shiny dark. Just like a galena. Do you remember this picture of galena? That's the way it looks like. Now, coming to their physical state, this one is a gas. This one is what? This one is what? This one is what? A liquid. Why this one is what? Solid at room temperature, right? On their physical state, gas, gas, liquid, solid. Now let's go here. Guess the one that should not be, that, like I said, all of them supposed to be what? Gases. But only one refused to be what? A gas. Can you guess? Guess. Which one is not a gas? Others, what did I say? I said all of them supposed to be what? Gases at room temperature, but one refused to be a gas. Why? Why and which one? Which one is that? Is it this one? This one? Okay, because this one is a, because you know this one is a liquid, right? You now think that this one should be a liquid. Sorry. Of all of them, the only one that is a liquid is this. If you go to chemistry, that is why you need to listen to understand. The question is, what made this one what? A liquid. Now, if I'm asked, which one is most gaseous here? Most gaseous. Isn't it? As you go down, the physical state changes from gas to what? Liquid to solid. Are you there? So, gas, more gaseous, less gaseous, liquid, and what? Solid. I seen that now. Solid at room temperature. But coming here is not like that. This one, all of them supposed to be what? Gases, because of their small molar masses and the weakness of the forces in them. But the only one that refused to be a gas is what? This one. The question is, why is it a liquid? It is a liquid, right? Not a gas. Now, see why it is a liquid. You see, there is what we call hydrogen force or hydrogen bond. I don't like calling it a bond because it's not a bond. Are you there? Now, That's what we call hydrogen bond. And a secondary force we call hydrogen bond. What is that secondary force? Hydrogen bond. Look at it. First of all, you need to know that for hydrogen bond to exist, note it, write it down. Only a molecule, only what? A molecule that has hydrogen. Only a molecule that has hydrogen linked directly. Only a molecule that has hydrogen linked what? Directly to fluorine. Linked directly to fluorine or oxygen or what? Oxygen. Either can form either intermolecular, can form hydrogen bond. Can form what? Hydrogen bond. Either with water molecule. With what? Water molecule or with another molecule. Or with another molecule of the same kind. Or with another molecule of the same what? Kind. Now, what do we say here? We said the only thing that will make a compound, a molecule. Okay.
Please, who is Chief Chiamaka? Are you here? Chiamaka Chief.
What is it? Open it. Open it. What is he talking about? What is he saying? What about Guinea? Oh, no, Nian. Here are heavy elements. Ferrovim. Another na ihe kwesịrị. All right. What do we say last class? The only thing that will make a molecule to form hydrogen bond is if what? If in that molecule you have what? Hydrogen linked directly to what? Fluorine, or with what? Or with what? Or with what? I didn't say another thing. Okay, go back. There's one I need to include there. Read that sentence again. Only what? A molecule that has what? Linked to what? Linked directly to fluorine or oxygen or nitrogen. Add nitrogen there. Or nitrogen. Full stop. Now look up here now. Can this man form hydrogen bond? Look at it very well. Yes. Can it? Yes. How do you know? He has hydrogen linked directly to what? Are you sure? Yes. Okay. Now, can this man form hydrogen bond with water? Yes. Can it? Yes. What about this one? Look, what about this one? Can water also form with itself? Yes. Can it form with itself? Yes, water can form with itself. Why do you say that water can form hydrogen bond? Do you see hydrogen connected to oxygen in water? Yes. That is correct. That is correct. That is correct. The question is, what are the factors that encourage or promote hydrogen bond? Who can tell me the factors that makes hydrogen bond impossible? Give me one. Note it. Factors promoting hydrogen bonding. Factors promoting what? Hydrogen bonding. What you need to pass UTME is principle. Is what? What you need are principles, guidelines, not copy note. That's why I say listen to understand. What are the factors that have promote or encourage hydrogen bonding? One is high electronegativity. High electronegativity of the atom bonded to hydrogen. High electronegativity of the atom bonded to hydrogen. High electronegativity of the what? Atom bonded to what? Hydrogen. Number two, small size of the atom. Small size of the electronegative atom. Small size of the electronegative atom bonded to hydrogen. Small size of the electronegative atom bonded to hydrogen. Small size of the what? Electronegative atom bonded to what? Hydrogen. First off, now look up. Who can tell me the most electronegative element in chemistry? In line with a Linus-Pauling table. Because there are many tables. Alfred Rachel table is there. So, and so many other tables. But the one we're accepting for now is a Linus-Pauling table. So the most electronegative element in Linus-Pauling table is what? Fluorine. And what is electronegativity? 4.0. The second most electronegative element is what? Oxygen. And the value is what? 3.5. The third one is what? The third one is this or this. This, which is 3.0. You see, nitrogen and chlorine have what? Equal electronegativity, right? Now, look up now. So, look up now. I want you to look at the first condition. The first condition for hydrogen bond to form is that what will happen? The element attached directly to hydrogen must be highly electro. Now, look at it. Is fluorine highly electronegative? Then, is it attached to hydrogen? Then this thing can form hydrogen bond. This thing can form hydrogen bond. Watch it again. Come to water. Look at water. Now, do you have hydrogen bonded to oxygen in water? Okay. Is oxygen highly electronegative? Yes, it can form hydrogen bond. So water can form hydrogen bond, right? Good. Hydrogen bond formation is a thing we're going to discuss. Now, look at this now. What about this one? The same thing. Something like this. This is what we call ammonia, right? Yes. Does it have hydrogen linked to nitrogen? Yes. Is nitrogen highly electronegative? Yes. Thank you. Now we come to this man. What about HCl? Yes. Is chlorine highly electronegative? Yes. Chlorine is highly electro what? But does HCl form hydrogen bond? Yes. Can HCl form hydrogen bond? No. The answer is no. Why? The second factor does not favor what? Chlorine. The first factor favors what? Chlorine. It favors all of them. Fluorine is small size. Sorry, fluorine is highly electronegative. Oxygen is highly electronegative. Nitrogen is highly electronegative. Chlorine is highly electro what? Negative. Now, fluorine is very, very small in size. Oxygen is smaller, oxygen followed by oxygen. Fluorine is smaller than oxygen. Oxygen is smaller than what? Nitrogen. But chlorine is large in size. Are you seeing it now? So can you tell me the reason why chlorine does not form, why HCl does not form hydrogen bond? Why? Small, is it small size or large size? Large size of chlorine atom is the reason. These are the things you need to understand to be able to tackle jam. They can ask you that in exam. Hydrogen chloride does not form hydrogen bond with water because, and here the reasons. Look for the fact that chlorine has larger. Okay, did you learn anything? Okay, look at this question now. Which of the following hydride molecule can form hydrogen bond with water? A. NH3. B. HCl. C. PH3. D. CH4. Which one? Is it NH3? Yes. Are you convinced? Very, very sure? Yes. Thank you. Now, there's another thing I need to let you know. You see, hydrogen bond plays enormous role in compounds where they exist. One of the roles or functions of hydrogen bonding is that it can transform a gas toward a liquid. Look at it. If a compound is supposed to be a gas and hydrogen bond comes in, is predominant in it, then that compound is going to be what? A liquid. It's going to be what? Now, remember what I said? All these things, all the hydrogen halides, HF, HCl, HBr, all of them are supposed to be what? All of them are supposed to be gases, right? Yes. Which one is a liquid? Is it this one? Yes. Can you think of why it is a liquid now? Yes. Why? Because the molecules are what? Held strongly by what? Hydrogen bond. And that's where you have the strongest hydrogen bond in HF. Okay? So these are questions. They are your past questions. They are. So now, if I'm asking again, which of these ones have highest boiling point? Hydrogen bond also has power to do what? Increase boiling point of a compound. So can you think of the one that has highest boiling point now? Is it this one? Yes. So this one has the highest boiling point. The boiling point is 19.5 degrees centigrade, while others are negative. Minus 8 something, minus 100 and something for these ones. Only this one is a liquid and it has the highest boiling point. Now, before we move away from them, of all of them, who can tell me the strongest acid among them? Hydrogen what? Iodide. Is hydrogen iodide? Which one is the strongest among them? Which one? Is it this one? Of all of them, which one is the strongest acid in water? This one is correct. Which one is the weakest? In fact, the strength is reducing this way. This is the strongest acid in water, followed by this, followed by this, followed by this. The question is why? Ask me why. Now, when we are talking about strength of acid, we talk about the readiness to do what? To release the hydrogen. And the readiness to release the hydrogen is determined by what? Strength of the bond holding it, right? If the bond holding the hydrogen is weak, that means it can easily break away. But if it's too strong, then it will not break away easily, right? The bond holding hydrogen here is too strong. Plus another hydrogen bond locking it inside. So for the hydrogen to liberate, to come out is very, very difficult. Are you with me now? So as a result, this is what? weakest of all. Why this is what? Strongest. Followed by this, before this and this. Another question I can ask you on this is, of all of them, which one has the highest entropy? Highest what? Entropy. Give the entropy. Degree of what? Disorderliness or randomness, right? Of matter. In other words, how scattered particles of matter are, right? How scattered they are. How scattered they are. So, who can tell me of all of them, which one has the highest entropy? Eh? Yes, yeah. Which one is the strongest? The strongest, the most reactive is what? This one. The weakest is this one. The only liquid is what? This one. Highest boiling point, this one. The only liquid, this one. Others are what? Gases. These two, in fact, these ones are what? Reducing agent. They're what? For that reason, you cannot use H2SO4 to do what? Dry them. They can use H2SO4 to dry this one. Are you with me? But not this one. These are practical things they ask in JAM. Okay, listen to this question now. Which of the following hydrogen halides has hydrogen bonds? A, hydrogen fluoride. B, hydrogen chloride. C, hydrogen bromide. D, hydrogen iodide. So hydrogen fluoride has the strongest hydrogen bond. Intermolecular hydrogen bond. Hydrogen fluoride is what I say. Hydrogen fluoride has the strongest intermolecular hydrogen bond. Eh? The one that has highest entropy. Okay, the high volatility, the molecule likes spreading. One is that the molecule is small in size, small to compare to this one. Okay, so they are lighter than this one. They spread at random, more at random than these ones. Okay, what now? If I ask you this, if I throw powder into the air and throw stones into the air, which one is spreading more? Powder, right? Why? They are lighter, right? So this one now is supposed to be the lightest, isn't it? But unfortunately, because of the hydrogen bond that brought them together, it could not do it. So what's the next thing that should do that now? HCl. Have you seen that? So it's lighter. The molecules are smaller inside. They spread more than the rest. Everything in science has a reason. Has what? The number 3 question here says, which of the following hydrogen halides is a liquid at room temperature? Hydrogen iodide A, hydrogen bromide B, hydrogen chloride C, hydrogen fluoride D. Hydrogen what? Fluoride. Now, before I will talk, I need to show you something. What? The last question is, which hydrogen halide is a liquid at room temperature? The option said, what's the answer? That's the answer now. It's meant to be what? So he said that hydrogen bromide is the liquid. You're asking that this one's supposed to be a liquid. Why? What's your reason? Why do you think it should be a liquid? Because bromine is a liquid. Huh? Okay, it's okay. Now look up. This is bromine and this is what? One thing in chemical reaction is that when elements combine, each of the combining elements will lose their what? Properties. They will change entirely to a new thing. So if hydrogen reacts with bromine to form hydrogen bromide, this one has property different from this one, right? When this has formed, the property of this cannot resemble any of this. Are you with me now? Are you with me now? So do not think that because bromine is a liquid, therefore hydrogen bromide will be a liquid. It doesn't work like that. Because this is a different thing from this and this. Are you okay? Now, the next thing you should consider now is shapes of simple covalent molecules. Simple covalent hydrides. Now look at this. This is ammonia molecule, right? What is the shape? What is the shape of this? The shape of this is what? Trigonal pyramidal. Trigonal pyramidal or trigonal planar. In stating the shape or in describing the shape of a molecule, you can employ two concepts, two theories. You can use the concept of hybridization theory. You can use hybridization theory. You can also use Vesper theory. So in Vesper theory, ammonia is trigonal planar. Trigonal planar. That is according to Vesper theory. But according to hybridization theory is what? Trigonal pyramidal. You don't need that. All what you need is this shape. Yes, I said according to Vesper theory, it's trigonal planar. According to theory of hybridization, it is what? Trigonal pyramidal. So none of this is correct. Now, we have another hydride, H2O. Molecule, right? Now, in hybridization theory, it is angular. According to Vesper theory, it is what? Bent. Bent. So water has bent shape. What about pH 3? pH 3, the same as what? Ammonia. Are you there? Are you there? This pH 3, what is the name of this? What's the name of this? Phosphine. So it has the same shape as what? Ammonia. Phosphine and ammonia have the same shape. Similar shape. Now, look at JAM 1993 question 12. It says, listen to the question here. Listen. Which group of chemical elements forms covalent hydrides that have pyramidal shapes? Which group of chemical elements form covalent hydrides that have pyramidal shapes? A, they gave you IIIA. They gave you IVA. They gave you VA. They gave you VIA. Which one is the answer? VA. Is it VA? Yes. Why do you choose this? The group 15, are you there? Yes. That pyramidal. Now you see how they jump coin their questions. Who can tell me shape of CO2? Linear. Who can tell me the shape of beryllium chloride? The same linear. Now listen to this one. Which of the following metals, which of the following metallic hydrides does not decompose before the melting point is reached? Is it little hydride? Yes. That is correct. Next question says, which of the following metallic hydrides exists as inorganic polymer? A. Calcium hydride. B. Magnesium hydride. C. Sodium hydride. D. Potassium hydride. Is it magnesium hydride? Yes. You are very correct. We say these two, the hydride of these two are what? Polymeric, right? Yes. They are macromolecules. Number 10 question here says, which of the following metallic hydrides has a coordination number of 6? Has a coordination number of what? 6. Give me coordination number. What is coordination number? It's a coordination number. Not very simple. OSS1 give me coordination number. It's a very simple something. Watch. If you go to your textbook and search structure of sodium chloride, listen carefully. In the structure of sodium chloride, you find out that every sodium ion, look up, in sodium chloride crystal, which is a simple cubic structure, simple what? Onadika Magi. Every sodium ion is surrounded by 6 chloride ion. 1, 2, 3, 4, 5, 6. Every sodium ion is what? So this number of chloride ion that surround one sodium ion is known as what? Coordination number. So this sodium ion is coordinating all the what? All the ions. All the anions. Okay? So somebody said, how do you know? What? Because you're preparing for UTM exam, all the simple commonest compound like sodium chloride that they normally use as reference element, reference compound. Make sure you know the coordination number. And what's the coordination number of sodium chloride? 6 is correct. So the coordination number of sodium chloride is 6. Then, what is it? Can we give answer to this question I asked before? Remember we said that all the group 1 metals form what? Ionic hydrides, right? Yes. All their hydrides. Listen, the hydrides of group 1 metals have similar structure with what? With sodium chloride. So lithium hydride and sodium chloride have similar structure, almost the same structure. The same with sodium hydride, the same with potassium hydride, the same with rubidium hydride, the same with cesium hydride. So all the hydrides of this alkali metal and sodium hydride, they have similar what? Structure. So their coordination number is what? 6. What you need to answer JAM directly is principle. Is what? Principle. That's all. That's why I told you need to change your mindset. Copy notes. No. Imakwa topics on a chemistry. EMA in 2 months to pass exam. Then the question here says, which of the following metallic hydrides has a coordination number of 6? A. Calcium hydride. B. Magnesium hydride. C. Sodium hydride. D. Phosphine. Is it sodium hydride? Yes. Because you listened. You guarantee. So that is about hydrides. I am Kochagona hydride. So can you say another topic now? So I've answered 10 questions. Now, we are going into hydrogen. Chemistry of hydrogen. Hydrogen. I actually call stories about hydrogen. Here na purple hydrogen before, but inflammable A. Inflammable what? Can you imagine that inflammable A? On a work processor, is hydrogen flammable? Does it catch fire? Hydrogen na catch alcohol. It used to be called inflammable air. And then, until Lavoisier changed the name to hydrogen. If I made Lavoisier change the name to hydrogen, you know, Lavoisier discovered oxygen too. He was killed around 1869 during a French Revolution. So, who can tell me why he changed the name from inflammable air to hydrogen? Why? Because, of course, you know, the concept of electrolysis was also discovered with what? Water. So he has seen that one of the components of water is what? Hydrogen, right? So he called it hydro. Hydro means water, yeah? Then gene has to do with information. So for the fact that when hydrogen combined with oxygen, it gives you what? That's how the name hydrogen came about. So the name hydrogen implies that if hydrogen reacts to oxygen, it gives you what? It gives you what? Water, which is hydro. A hydro compound. Now, another thing you need to know is the abundance of hydrogen. You need to know that. Who can tell me the most abundant element in the universe? Hydrogen is the most abundant element in the universe. No one in the mana, whether in the sun or in the stars, hydrogen. Remember when we talk about universe, we're not talking about the earth. I hope you know. I'm talking about the entire universe, both planets and the stars. The most abundant element in the universe is what? Who can tell me the second most abundant element in the universe? Eh? Sorry. Your name is sorry. The second most abundant element in the universe is helium. 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 In fact, scientific data shows that listen, 92% of the entire universe is hydrogen. While 7% of the remaining universe is what? Helium. 1% is for every other element together. Imagine that. So the sun itself is made of about 70-something% of hydrogen. Only the sun make up the sun. So hydrogen is a very abundant element. But why do we not have enough hydrogen on the earth? In the air, in the atmosphere? Do we have enough hydrogen in the air? No. Why? Who can tell me why? Hydrogen is not abundant in our what? Atmosphere. Why? You want to know why? Yes. Well, look at the reason, because it's part of the question that you will encounter in physics. You can't physics now, and it's in your physics past question. If a man hydrogen are not enough in the air, is physics. But I will give you the question. Now look at it. Who can tell me the lightest element? Hydrogen. Lightest element is what? Lightest. It has the smallest mass. Hydrogen, right? Do you know about escape velocity? Yes. Get the escape velocity of a planet. Every planet has what we call escape what? na escape velocity. Enwudiri velocity speed in eji we to okwute na. Nto okwute ntune de okwute that stone will not come back to the earth again. And even it will escape into another planet. That speed I have the because you need to know the meaning of escape. Escape velocity, the minimum velocity you can give to what? An object, so that it can escape from what? The gravitational influence of what? A planet. And even minimum, the smallest, the minimum velocity you can give to what? An object that can be given to an what? Object, so that it can escape from the what? Influence, the gravitational influence of what? A planet. That is known as what? Escape velocity. Now listen carefully now. If the escape velocity of the Earth is 11.2 kilometer per hour, per second rather. 11.2 kilometer per what? Second. That is the escape velocity of the world, Earth. So if I want to throw a stone so that it will get away from the Earth, the velocity I will give to it is what? It has to be, every 1 second, it has to be covering a distance of what? 11.2 kilometer. If you can give a rocket 11.2 kilometer distance in 1 second, every 1 second, it will cover a distance of what? Then it is likely to escape from the planet. So this is the escape velocity of what? Earth. In an even 11.2 kilometer per what? Second. That is the escape velocity of the world. Now listen carefully. Listen carefully. If I give 11 kilometer, if I make a rocket to be traveling 11 kilometer in 1 second, can it escape from the Earth? No. Can it? No. What if I give the rocket 11.2 kilometer, a velocity of 11.2 kilometer per second? Can it travel? Can it move away from the Earth? Yes. No. The answer is what? No. You see why I said try to understand. Look at what we said escape velocity is. We say it's the minimum. Minimum means the smallest. Which means if you want it to escape, you need to give what? Higher velocity. So if I give velocity of 13, can it escape? Yes. It can escape. But 11.2 it cannot escape. 11.2, it will be at the outer surface of the Earth. It will not escape. It will just be around the outer surface. But if you give it more than 11.2, it will escape from the Earth. The question now is, why do we not have enough hydrogen in our atmosphere, in our air? Speed of hydrogen molecule is more than escape velocity on the world, Earth. So anything whose escape velocity, whose velocity is more than escape velocity of the Earth will not like to stay on the world. As it forms, it will fly. So the velocity of hydrogen molecule is more than what? More than 11.2 kilometers per second. For that reason, hydrogen will not be enough in our atmosphere. Let me repeat what I said. Do you agree that for an object to escape from the Earth, it needs to possess a velocity more than the escape velocity of the Earth? Yes. Do you agree with that? Yes. Now, we are trying to give reason to explain why we don't have enough hydrogen in our air. We don't have enough hydrogen in our air because the velocity of hydrogen molecule is more than what? The escape velocity of the Earth. So as the hydrogen is produced, they'll move away from the Earth and go into the sun and other planets. Are you with me? Is that understood now? Okay, you may note this. Hydrogen is the lightest chemical element. Hydrogen is the lightest chemical element. Hydrogen is the lightest chemical element. Is the lightest chemical element. Lightest. Full stop. Amount of hydrogen in the Earth's atmosphere. Amount of hydrogen in the Earth's atmosphere. Earth's atmosphere. Amount of hydrogen in the Earth's atmosphere. Amount of hydrogen in the Earth's atmosphere is very small. Is very small because either is very small because the mass of hydrogen molecule is very small, because the mass of hydrogen molecule is very small, because the mass of hydrogen molecule is very small, and the speed of hydrogen molecule is more than escape velocity of the Earth. And the speed of hydrogen molecule is more than escape velocity of the Earth. What is the escape velocity of the Earth? Kilometer per what? Second. So if a body traveling upwards is given a velocity of more than 11.2, will that body likely to come back to the Earth again? It is most likely to do what? Leave the Earth entirely and never return back again. Are you with me? So that is the reason why hydrogen is not enough here. Now, who can tell me 3 ways hydrogen atom can become stable? What is the electronic configuration of hydrogen atom? 1s1, right? 1s1. Which means it has just one electron, right? Is this stable or not stable? It's unstable, right? So hydrogen won't attain stability. By doing what? How will it become stable? It will try as much as possible to have 2 electrons, right? So to have 2 electrons, when it's now having 2 electrons, that is now what? That is now, which atom is it resembling now? Helium, right? And helium has 2 electrons, right? We call it duplets. Duplets. Helium is the only noble gas that has duplet electrons. Duplet what? Duplet structure. Valence structure. Now, my question is, can you tell me how hydrogen can attain the electronic configuration of helium atom? Tell me ways you think hydrogen can become stable. How it can acquire 2 electrons like helium. How can it do that? By what? By gaining 1 electron. By what? By gaining what? So, for instance, when sodium interacts with hydrogen, what happens? Sodium will give 1 electron to this, right? So you have this and have this. So by this here now, how many electrons is this man having now? 2, right? So you can now see that in hydride, the electronic configuration of hydrogen hydride is what? 1s2. Because that's in ionic hydride though. In ionic hydride, the electron configuration of hydrogen atom is what? 1s2. In ionic hydride only. 1s2. That's this singlet electron configuration. So there are 3 ways hydrogen atom can attain the stability, the stable electron configuration of helium. Note it down. Hydrogen can achieve the stable electronic configuration of helium atom. Hydrogen can achieve the stable duplet. The stable duplet electronic configuration of helium atom. Hydrogen can achieve the stable duplet electronic configuration of what? Helium atom by number one, forming a covalent bond. Forming what? A covalent bond. Or sharing 2 electrons with another atom. By forming covalent bond or sharing what? 2 electrons with what? Another atom. Number 2, by gaining 1 electron, from group 1, by gaining 1 electron from group 1 or group 2 metal. By gaining 1 electron from group 1 or group 2 metal. Is it all the group 2 you can gain 1 electron from? You know the ones you can gain from? Can you gain from calcium? Can you gain from strontium? Can you gain from magnesium? No. Number 3, by losing electron. By losing what? Electron. By losing what? Electron. Now, you see, there's something that normally happens. Sometimes there are some human beings that if you give them food, if you give them something, they will reject that thing. When they see that what you have given to them is not enough, they will give it back to you. Have you done that before? Your mommy gave you something and you reject it. When you reject it, what do you expect from her? Bigger one, right? Imagine Nina Rununo now, mommy edosegi sauce of biscuit 15 naira. Siki where amend if Are you gonna be happy? After came in mucha chemistry, in a sucha chemistry, sucha physics, sucha any neighbor. I am one that is Iran and Wuzugoko. I will look an apple in you. When I don't know, you one biscuit, Keta. Here, does see I will pre open me. Then, Kina choke a melody, Camerigan keys, right? Now, no hydrogen name. Since hydrogen has just 1 electron, now, what will you need to do if you cannot gain and you cannot share with another one? Look up, like in this one now, what is he doing here? He's sharing, right? He's sharing how many electrons now? He has 1, right? Why fluorine has how many? Fluorine has 2 here, am I right? You know this one is 9, 2 of us. He has 2 here, has what? 8 here. Am I right? Sorry. He has 2 here and then 7 here, right? Making it what? 9. So let me put it this way. 2 and 7. 1, 2, 3, 4, 5, 6, 7. 7. 1, 2, 3, 4, 5. So the 7th one will be here. Now, by the 7th one being here now, hydrogen has what? 2. Fluorine has how many? 1, 2, 3, 4, 5, 6, 7, 8. Sorry. 1, 2, 3, 4, 5, 6, 7, 8. Yes. That's what I mean by sharing. It's like set in mathematics. Do you remember set in maths? Yes. Mathematics. So if I have 1 and 2, and I have 3 and I have 4 here, this is A and this is B, and I ask you, list the element of A, what will you answer? What are the elements of A? Elements of A are 1, 2, 3. So A is sharing 3 with what? Sharing 1 and 2 with what? Which is 1 and 2 belong to A and also belong to B. That's what you see here. That's what I mean by sharing of electron. Is it right? Now, but in some cases, look up. Hydrogen we prefer to lose completely. Now, when hydrogen loses just 1 electron at home, or chobazi bo, and I even know. Oh, yeah, releasing Conway 2 4 ya. Chobazi ya naragini 2. Then obviously way to electron or say biaba nari the thing. So now I can go see Koseme. Look up so they understand it. Hydrogen can lose that electron on way. When it loses it, it forms a proton. This is what? So proton has no electron. Proton has no electron. Now, this man and 1 electron, it has lost that 1 electron it has, right? It will now look for something that has 2 electrons to collect from. So that can happen when you see something like ammonia. Ammonia with 2 electrons on a use bay. Eh? Well, let's find out. Look at ammonia. Do you remember the valency? What group does nitrogen belong to? Group 15 in the current, 5 in what? Ancient. One advantage of the ancient configuration, ancient grouping, is that it gives you number of valence electrons. Number of what? The old one corresponds to number of what? Valence electron. So all these elements here have how many valence electrons? 5. All this one here have how many? 4. All these ones here have how many? All these ones here have how many? That is an advantage of the old one, but it has a lot of faults. That was why we abolished it in 1912. Now, look up. Look up now. So, nitrogen has how many valence electrons? 5, right? So, 5 come where? 5 come where? How many co-use go to form this bond? O-use go 3. 1, 2. O-use go 3 in forming bond now. Only can we left? 2, right? Iba on where or metuberea free. Okay, again. That 2 electrons on a metuberea kone is we cannot go lumpe. Say lumpe. Say lumpe. Or non-bonding pair. Say non-bonding pair. So nothing can add form bond. So I join how many lone pair can money and what will you answer? Give me a pair. A pair with 2, right? So how many pair never now? Oh, when did I see 2? Because nature no nature. 2, how many pair? 1 pair. 1 pair be here, boy. If I say a pair of shoes, Kia and Yegi left and Yegi right, that be a pair of shoes. A pair. So now, ammonia has how many lone pair now? Is it 1? Yes. 1. Mad or ya go how many lone pair neighbor? Madam wake gwan how many lone pen on our water. You have to jump questions. What kind of there? K group oxygen on here in the periodic table. How many valence electron come where? Okay. Are you sure 6? 6 is correct. Now let's find out how many can you use Goreba? O is go to, right? Only for now. O met better for haka. So how many lone pair now? 2 lone pairs. So water molecule H2O has 2 lone pairs. While ammonia has how many? 1 lone pair. Now, and we find out what ligand. Say ligand. Say ligand. What there? Etanke marry ligand. Here me favor ligand. You can see my form. A ligand or a ligating agent. A ligand or a ligating agent. A ligand or a ligating agent is an ion or a molecule. Is an ion or a molecule. A ligand or a ligating agent is an ion or what? A molecule that has 1 or more lone pairs. That has 1 or more lone pairs of electrons. A ligand is an ion, a molecule that has what? 1 or what? More lone pairs of what? Electrons. So how many lone pairs can ammonia wear? 1 lone pair. So is ammonia a ligand? Yes. Eh? Yes. Is ammonia a ligand? Yes. If you get men this no kia, they had drama. Oh, when did they still have more ammonia? I could favor ligand. Now ligand is wegini 1 or more lone pairs. That's why he gained to come madani de yed. Blessed are those that listen. If you forget, get monty. If you open him water, I put on a brain now. On this brain. On this brain. Can you get objective question? You get like multiple choice. You get choices. And an even nepu. Man ordinary jog ya in wiki mansa time and immediately you go option that means not stored in your brain. Man anything in nuberonanti before. Eh? Or not on a brain now. And you get a question. Chances in here they are about 99.9%. Now, is this man a ligand? Yes. What about H2O? Is it a ligand? Yes. Yes, you have a ligand. You have a ligand. Now watch. So this man and this man, can they react? Look up now, they can react. Because this man doesn't have an electron, but this one has how many? It has how many lone pair? So this man would donate the lone pair. It will donate the lone pair to this man. And it will accept it. When it accepts it, it will form what? NH4 plus. This is called what? Ammonium ion. Now look up. Let me draw the structure of this. Let me draw the structure so that you can see it very clearly. Now look up. Look up very carefully. Very, very carefully. Can you see anything? Do you see anything here? What? Did you see anything? Did you notice anything? What did you notice? One line has arrow, right? Thank you. These ones are the ones in what? Ammonia. This one now is one that formed when this and this interact. It is called coordinate bond. Say coordinate bond. So we use arrow to do what? To do what? To denote a coordinate bond. So the bond that forms When hydrogen ion interact with ammonia molecule is what? It's coordinate bond or dative bond. Say dative bond. Dative. Dative or coordinate. Coordinates or dative. That is this bond that has arrow. Dative or coordinate. Now look at this one too. Can the same thing happen here? Tell me what will form here now. What will form here now? If this and this interact, what will happen? H3O plus. This is what? What is the name? Huh? Hydrogen. Hydrozonium. It's about hydronium, not hydrozonium. Hydronium, not hydrozonium. Now look up, because your name on over on Agulako. And we found out about ozonum ion. Gini bo ozonum ion. Ozonum ion mbo. Ion we positively charged oxygen. Positively charged what? And we found out former charge. And any ion former charge on oxygen is an ozonum ion. This man belongs to a class of chemical species called ozonum ions. Called what? So it's an example of ozonum ion. In an even Nakawa is an example of what? Ozonum ion. It's an example. It belongs to ozonum ion family. Why? The positive charge is on what? Oxygen. And an even Neku. So, is an example of ozonum. There are so many ozonum ions. But because water is involved here, that's why it is called what? Hydronium. Okay? Hydronium. That's the proper name. Hydronium ion, not hydrozonium ion. Take note of that. They can use that to tempt you in exam. So, in all these examples I've given you here, what is playing out is that hydrogen has lost the electron it has, and now look for something that has what? 2 electrons they can collect once. And when that is happening, coordinate bond is what? Forming. Why did the coordinate bond form? Who can tell me why? Because in normal covalent bonding, the 2 atoms supposed to do what? Produce electrons and share. Is it right? Each one will produce and then they will share together. Is it right? That's normal covalent bond. Coordinate is when one person is one producing and 2 of them are what? Enjoying it. Just like you go to ShopRite with somebody. You know that person? You know that person? When you go to ShopRite with somebody and then you order for pizza, somebody order for pizza, somebody. And after purchasing the pizza, they will come together and be eating the pizza. Sometimes only one person will be eating the pizza. Then when you ask the other person will ask the other person, are you not eating? He said, no, I ate this in too much yesterday. I've eaten it too much this morning. Some people do like that. I've seen people who do like that. Let's move because we don't have time. I know when I enter this class. I know when I enter this class. Don't you know? I know. That was them. When they see me to in a worker. Before I leave you, write this. Gasification. 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 Gainable gasification. Ngage monte. Here kita non-adjunct question, not less than 8 questions. All of this. Okay, right. Gasification is a heterogeneous process. Is a heterogeneous process. Is a heterogeneous what? Process whereby the organic parts, whereby the organic what? Parts of a solid fuel, see it on the board, fuel, F-U-E-L. Is firewood a fuel? Yes. Are you a fuel? Yes. Can you burn? Yes. You can burn. Anything that can burn to produce what? Fire or thermal energy is what? A fuel. Is your clothes a fuel? Yes. Is your hair fuel? Yes. That thing you are carrying on your hair, is it a fuel? Yes. Yes. So anything, don't think that, don't you ever say, na mommy singers to carry up fuel. Ask one with dear because in your medical. Fuel, in fact, if you are not some nature of fuel and you give firewood, I will give you anything I like. If you want something for your generator, order for petrol or gasoline, not fuel. Are you with me? Now let's move. We said that gasification is what? A heterogeneous process of what? Whereby the organic what? Part of a solid fuel is converted to combustible gases. Is converted to combustible gases. Is converted to what? Gases. By, are you there? By the action of a blast. By the action of what? A blast. A blast. Example. What are examples of blasts? Steam. Steam is a blast. Oxygen. Stroke air. Oxygen stroke what? Air. ETC. Now, who can tell me this very process here is what is used to produce what? Water gas. Have you heard about water gas? Yeah, water gas. These are examples of what? Combustible gases. And they are called few gases. Few what? These are few gases or combustible gases. Few gases or combustible gases. Of course, few gases are mixtures of combustible gases. You have water gas. You have again producer gas. Producer gas. You also have what? Synthesis gas. You have coal gas. You have coal gas. You have town gas. Town gas. You have coke oven gas. You have synthesis gas. All these are few gases. Now, nke ndị jam na use carry bụ nka and nka. KK with the water gas. Gasification of what? Red or white hot coke. Gasification of what? Red or white hot coke. By action of steam. By action of what? Steam gives water gas. What I say? Gasification of what? Red or white hot coke. Gasification of carbon. Gasification of red or white hot coke with what? By action of what? Steam. Gives what? Produces what? Water gas. What is water gas? Look at what is a water gas here. Coke with steam. Coke is a good reducing agent, right? Yes. For that reason, it will reduce water to what? Hydrogen. While itself was dies to what? CO. So a mixture of hydrogen and carbon dioxide is called what? Water gas. How did you get it? By gasification of what? White or what? Red coke. By action of what? Action of what? Steam. Miracle. That's how you get water gas. So water gas is a mixture of this and this. There are technical questions there. I would like to treat next time. Now, where you are going, what about producer gas? How do you get producer gas? Gasification of what? Gasification of what? White coke. By action of what? By action of what now? I gave you possible examples of blast. The product depends on the blasting agent used. If the blasting agent is steam and it's acts on coke, the product is what? Which are mixture of what and what? Hydrogen and what? Carbon 2 oxide. Carbon 2 oxide. Carbon 2 oxide. From this water gas, we can get this hydrogen by converting this CO to CO2 and then subjecting it to scrubbing. To what? Again, it was scrubbing. Washing under pressure. Washing in what? Washing under pressure. Under pressure. I was scrubbing. Eh? Score. Okay, I'm going out. So to get producer gas, you get producer gas by what? Gasification of white coke by action of what? Air. Action of air gives producer gas. Gasification of what? White coke by action of what? Air. White coke, yes. Never. Coke. Of course, oxygen should not be enough. That's why it needs to be air. So here, this is going to change to this, and then this will remain as a residue. Because nitrogen is not a reactive gas, isn't it? Eh? Now, you can see, producer gas is a mixture of what and what? Carbon dioxide and nitrogen. If I may ask you, water gas and producer gas, which one is a better heating fuel? Which one is a better heating fuel? Do you have reason? The two components of water gases are highly combustible, right? But these two, only one is what? Combustible. This one is not combustible, isn't it? So water gas is a good fuel. It's a better fuel than producer gas. I wish you good luck. What? Synthesis gas. You want me to talk about synthesis gas? Synthesis gas is produced by what? By action of steam. Action of steam on action of what? Steam on a hydrocarbon. What did I say? Synthesis gas is produced by what? Action of steam on what? Action of steam on what? Hydrocarbon. Give me example of that hydrocarbon. Methane. That's, you get it from where? Natural gas. You know methane is the main component of natural gas. You can also use ethane. Any hydrocarbon can serve. So that is synthesis gas. I wish you good luck.